Welcome back. In this video, we'll look into combined science paper code 5129 of paper 1, May-June, year 2010. I'll only walk through the physics section, which only consists of from question 1 until question 13. Let's begin. Question 1. Question 1 states that the diagram shows a method of measuring the diameter of a beaker. Assume that this circular thing is a beaker with a ruler on top and wooden block to prevent it rolling on the bench. Question asks, what is the diameter of a beaker? The beaker. So, the beaker starts from this section right here and up till here until 8 centimeter mark. If we read the first one, it'll be 3.5 centimeter mark. Is that the end? No. We need to find the difference between these two numbers in order to find the diameter of a beaker, this beaker. So we need to deduct the 8 centimeter with 3.5 centimeter. You can use mental maths or you can use your calculator, which is easier for your life to do so. So that will be 4.5 centimeter as shown in option A. Alright, next, moving on to question 2. A block of mass 1 kilogram is pushed across a frictionless surface with a force of 2 Newton. What is the acceleration of the block? Alright, this question, they have given you the mass, which is 1 kilogram, and the force of 2 Newton. Force is equal to 2 Newton, while mass is 1 kilogram. Question asks about acceleration. We don't know acceleration, but we can relate this question to this equation. F equal to ma, which is the Newton's second law. To find acceleration, we need to make a as a subject. So a is equal to force divided by mass. Force is 2 Newton and mass is 1 kilogram. 2 divided by 1 is still 2. 2.0 meter per second square, as noted by the units of acceleration. So the answer is shown by option C, which is 2 meter per second square. Right, next, moving on to question 3. Question 3, the diagram shows 3 pieces of apparatus. Apparatus 1, balance, second one, measuring cylinder, and the third one, vernier calipers. Which instruments are required to measure the density of an irregular piece of rock? Okay, first of all, the keyword here is density. Second is irregular. Density, which is denoted by rho here. I'll write here down. Rho is equal to mass divided by volume. To measure the mass, we need a weighing balance, or in this case, it's just balance. So we need number 1. To measure the volume of an irregular piece of rock, the only thing we can use among these 3 instruments is the measuring cylinder. You can measure the first volume, which is volume of water, Then add with the rock, irregular piece of the rock, then measure the second volume. So let me write that down. First volume will be the volume of water inside the measuring cylinder. Second volume will be volume of water with the rock. If you were to deduct both of this volume, you'll obtain the volume of the rock. Alright, setting that aside, so we got our two instruments which is needed for this very question: the balance and the measuring cylinder. So number 1 and number 2, which means the option is A, 1 and 2 only. Option 3 here is only used to measure small objects such as coin, internal diameter of a tube, test tube, so test tube, and some more. For now, let's just focus on this one. Alright, moving on to the next page, which is question 4. A diver weighing 720 Newton stands at the end of a springboard measuring 3 meters long. This is the diver, this is the springboard. Question asks, what is the moment about the support? Alright, the support. Let's see that this is the support. Or else, how would the springboard still remain horizontal? Next, the question asks the moment. We know that moment is equal to force times the perpendicular distance between the force and the pivot, or in this case is support. So using this equation, let's draw more arrows going up. Okay, using this equation, we know our force. Our force is the weight. Force in this case is the weight. Why? Because they both have the same units. Force is measured in Newton as well as weight. So that will be 720 Newton multiplied with the perpendicular distance. Weight is vertical, whereas this distance is horizontal. Therefore, these two are perpendicular against each other. So the distance here is 3 meters. Now we don't need to solve it because we just need to match against among the answers here. So this 720 Newton multiplied with 3 meter is a match with option B. So our answer is option B. Okay. Along with the units, Newton meter, you just multiply them together. That'll give you Newton meter. On to the next question, question 5. Question 5. Which energy source is used in nuclear power station? Alright, the keyword here is nuclear power station. This is one of the factual questions. So among all of this option A, B, C, D, you can see that this is fossil fuel. Option A is a fossil fuel, so automatically A is out. And C as well. C is a fossil fuel. Alright, how do we write fossil fuel? Okay, there we go. Hydrogen, nope. So the last option is uranium. Uranium is a radioactive source which is used in nuclear power station. Radioactive. Therefore, D is the answer. Moving on, question 6. Equal volumes of 4 substances are heated at atmospheric pressure. The temperature rise is the same for each substance. Which substance expands the most? Again, this is one of the factual questions. So I'll run through this question. There are 3 states here. We know that one of it is solid. Second will be liquid. Third will be gas, or known as air. So among these 3, solid has the most or the strongest intermolecular force as compared to liquid, and as liquid compared to gas. So gas has the least intermolecular force. Let me just put it as IF. So when it is heated, the one that will be expanded the most will be gas. As they have weak intermolecular force as compared to these other 2 states. Therefore, gas is the answer. Or in this case, between all these 4, it will be air. Air is the answer. Alright, moving on to the next question. Question 7. Oh dear. Okay. Question 7. The diagram shows a plane mirror and the position of an image. Where must the object be placed to form this image? Alright, judging from the diagram right here, the image is here, as you can see. This is the mirror. They're expecting us to know where the object will form the image. So, from what I can tell from this diagram, you must detect where the object is in order to get this image, which is behind the mirror. The mirror is here, behind the mirror is here. So the object must be standing right in front or directly in front of the mirror, which is option D. As you are standing in front of the mirror, you'll be able to see the image of yourself behind the mirror. That's one example. Alright, next. Question 8. A battery moves a charge of 60 coulomb around a circuit in a time of 20 seconds. What is the current in the circuit? Alright, so there are 2 key points here, maybe 3 key points here. First is the charge. Charge is denoted by Q, which is 60 coulomb, and the time here is 20 seconds. Question asks the current, which is the I. So we can all use the formula I is equal to Q divided by T. When you substitute this Q and T, you have 60 coulomb divided by 20 seconds. Oh dear, this seconds doesn't look like seconds. Okay. When you divide 60 divided by When you divide 60 with 20, very sorry about that, you'll get 3. The units will be in amperes. Why? Because we're finding I, which is the current. So when you match among all these options, you'll get B. B as 3.0 amps. Next, question 9. Alright, next. Question 9. A current of 6 amperes flows in this circuit shown. The current splits up when it enters a parallel branches of resistors, as you can see here. What is the reading on the ammeter? Alright, without giving us any other value other than the current and the 2 resistance, which is 3 amps and 3 amps respectively, we're expected to know how to divide this current into these 2 branches. So there are 6 amps entering from the main branch. I'll call this the main branch. It will be then split into 2 branches right here. Branch number 1, branch number 2. The current split between these 2 branches is determined by the resistance of the resistor in each branch. We can see that both resistance in the 2 branches are equal to each other, 3 ohms, 3 ohms. So that means that the current of these 6 amps can be equally divided by 2 branches. This only applies when the resistor in the branch are equal to each other. So therefore, each branch will have 3 amps, which means it will be the option B. Alright, we solved question 9. Now on to question 10. Question 10. A small heater operates at 12 volts with 2 amps. How much energy will it use when it is used for 5 minutes? Okay, there are few factors here which I need to write down. First factor is 12 volts factor, or I'll call it terms. I'll keep using the word factor here. Second will be the current, which is 2 amps. Then we are given minutes, which is time, 5 minutes here. And they are asking about energy. We need to know how much energy. Energy is denoted by the question mark. With the use of this formula, energy is equal to IVT. We can then find the amount of energy used. I is 2 amps. Oops, maybe I shouldn't use bracket. Okay, multiplied by V. V is 12 volts multiplied by 5 minutes. But then here's the catch. The time here should be in seconds. Therefore, the minutes shall be converted to seconds by the method of multiplying 5 minutes by 60 seconds per minute. Since minute and minute will cancel each other off. With the use of your calculator, you'll be able to get the answer. Hold up, let me use my calculator. Okay, that will give you 7,200 joules, as energy is measured in joules. So that'll give you the answer D, 7,200 joules. Alright, moving on to the next page. Question 11. Wait, hold up. Let me zoom out first. Alright, question 11. Which diagram shows the correct connection for a switch and a lamp in a lighting circuit? Alright, you have given these options right here, and you're given the keys on this side. Okay, before we move on to each option, I would like to write down next to the key what each of these keys should be connected to. Okay, first of all, L, which is denoted by live wire. Live wire is always connected with switch first. A switch, then the component. Whereas neutral wire, the function is just to complete the circuit. The earth wire is normally connected to the metal casing of the component. This is to prevent electrocuting the user. Then metal case is just metal case. That's it. Alright, now that we have identified what are the keys is used to connect with, now let's move on to option A. We can see that option A, hold on, let me use a laser. Option A, we can see that the live is connected with the switch, which is correct, and also to the component, which is the light bulb. But we can see that the metal casing right here is connected to neutral wire. So this is not a correct setup. Next, option B. We can see that the live wire is straight away connected to the light bulb. There's no switch beforehand that, but there is after that. There's a switch after the light bulb, which is then connected to the neutral wire. Even though the earth casing is correct, this is a wrong setup because the user might get electrocuted if any faulty were to happen to the user, as there is no switch before the component. So B is out of the option. Now let's move on to C. The live wire is connected to the switch first, which is a correct setup. Next is to the lamp. Then the lamp Then the lamp completes the circuit with the neutral wire, whereas the earth wire connects with the metal casing. This C is a correct setup, but let's have a look at option D. Option D, the live wire is connected to the metal casing straight away, whereas the neutral wire is connected to the switch and the earth wire is connected to the light bulb, which is a wrong way to set up the circuit. So C is the only correct way to set up this circuit. Okay, let's move on to the next question, which is question 12. Question 12. What particles are present in the nucleus of the oxygen nuclide 17,8 oxygen? 17,8 O. Okay, as you note right here, really big. So the options given are between neutrons and protons. In this nuclide, we can identify that the proton here, as I write it down as P, is 8. This 17 is a mass number. We know that mass can be written with this form of equation. Mass is equal to proton plus neutrons. Since we know our mass, which is 17, our proton is 8, we can find out what's the neutron by making neutrons a subject. 17 minus 8 will be 9. So now we got our numbers ready. Let's match it with the options here. Neutrons is 9. So we have two options here that shows 9. So B and C matches the option here. Whereas proton is 8. So the only option that's matching is C. C is the correct answer. Okay, on to the last question. Let me zoom in better. Okay, there we go. Last question, question 13. Which particle is positively charged? So among all this, okay, let's deal with each of it one by one. Electron. We know that electron is a negatively charged. Yes, it's a negatively charged particle. Neutral atom, as denoted by the name or the term neutral. The charge is 0, or there's no plus, there's no minus. Neutron, it is neutral as well. There's no plus, there's no minus. Proton is a positively charged particle. So D is the answer. This is more of a factual question. So there we end our session with star and a cloud. Okay, the end. We'll see you in the next video.